the states of matter in a little bit more detail. So at STP, two forms of solid carbon and diamond have different properties because they have different chemical composition, and they also have different structures. So let's look at the options. Diamond has a different percent composition than graphite. Diamond has more electrons per atom than graphite, which is not true because we know they are both made of carbon. Diamond has stronger hydrogen bonding than graphite. Could be true. The question kind of doesn't quite give us enough information. Diamond has a different crystal structure than graphite. So the 1% composition is also something that we don't have enough information for in the question because we don't know the formula. And then for the hydrogen bonding, we know that it's made of carbon. We don't know if there are any hydrogens, right? So we don't know if there is any hydrogen bonding. So that is also something that we don't have information for. So the only option here is number 4. So which property is determined by the structure, arrangement, and interaction of the molecules of a substance at a given temperature and pressure? So all of these things can give us information about the phase of matter or the physical state of a substance. Which sample of matter has the greatest distance between molecules at STP? So greatest distance is very specific to gases. Sample of KCl solid is dissolved in water to form KCl aqueous solution. When the water in KCl is completely evaporated, KCl solid remains. Which statement describes the property of KCl solid after the water evaporated? So the KCl becomes a molecular compound. Well, that means KCl is not KCl anymore, so that's not true. The molar mass of KCl decreases. No, it will not, because it's still KCl. Same formula, so molar mass is not impacted. Melting point of KCl is unchanged. That is also something that depends on the identity of the substance. So as long as it's still KCl, melting point will not change. KCl conducts an electric current. KCl solid conducts an electric current. This is something that could be impacted because we said that in ionic compounds they don't conduct when they are a solid, but they do conduct when they are in the aqueous solution. So identify the substance in this table that is a liquid at STP. So we are given, the only thing that we have here to make a comparison is the melting points and the boiling points. We do know, based on our prior knowledge, that some of these things, fluorine, bromine, iodine, we know they are gases. Bromine is a liquid, by the way. We know for sure fluorine is a gas. So what you do need to know, however, is that as the particles come closer together, their melting and boiling points increase, because then it's harder to separate the particles to change their phase, or to break the intermolecular forces to change the phase. So when we go from gas to liquid to solid, the boiling point and melting point increase. So if you're comparing maybe gases and liquids here, actually they did not specify if you're only comparing gases and liquids. Interesting. Okay, well, this is something that you do have to remember, keep in mind. There was most likely some information before this that I did not put in the question that would have been more helpful, but something that we did write in our notes that you should write in your notes if you don't have it already is that bromine is one of the only 2 liquids at room temperature. So your answer will be bromine in this case. The other liquid, by the way, is mercury. State how the molecular motion of the water molecules in the beaker changes as the temperature increases. So remember, temperature is defined as the measure of kinetic energy. So when we are increasing the temperature, that means we increase the kinetic energy of the molecules. So that means now they are going to start moving faster. So that's your answer. Just have to say that the molecules or the particles start moving faster. Which term identifies the strong intermolecular forces found in a sample of liquid water? So we have got 3 different types of bonding. Remember that bonding is not intermolecular force, because bonding is intramolecular. It is between or within the same molecule. Intermolecular forces are between different molecules. So the only intermolecular force here is hydrogen bonding. Which statement explains the low boiling point of hydrogen at standard pressure? So hydrogen has strong covalent bonds. Hydrogen has, it doesn't have covalent bonds, at least not strong, because it has non-polar when you have 2 hydrogens. So hydrogen has weak covalent bonds, hydrogen has strong intermolecular forces, hydrogen has weak intermolecular forces. So we don't need to look at the bonds in general, because boiling point is mostly impacted by the intermolecular forces. So if something has a low boiling point, that means the intermolecular forces are weak. So let's make a note of that as well. Low boiling point means low intermolecular forces, because that means it is very easy to break those intermolecular forces and change the phase. What's the vapor pressure of water at 90 degrees Celsius? This is something that you are going to have to answer using table H. So you can just look at table H, go to 90 degrees Celsius, go to water, find the vapor pressure. Based on table H, once again, which compound has the strongest intermolecular forces at 60 kilopascal? So in table H, at 60 kilopascal, the substance that has, okay, so table H can give us information about the vapor pressure and also about the boiling point. So if you're looking for strong intermolecular forces at this specific vapor pressure, then we are looking for the one that has the highest boiling point. So according to table H, the one that has the highest boiling point is ethanoic acid. Based on the boiling point, compare the strength of intermolecular forces in 1-chlorobutane and the strength of intermolecular forces in 2-chlorobutane. So once again, that's a comparison question. So you can simply say which one has a higher boiling point. Which one has stronger intermolecular forces. So because 1-chlorobutane has a higher boiling point, that means this one is going to have stronger intermolecular forces. Based on table I, which equation represents conservation of mass and energy? So to answer this question, you're going to have to go to table I and look at the equation for the combustion of methane. So that, I believe, is the very first equation in table I. And the energy or the heat for that reaction is negative 890.4. So if your delta H is a negative number, that means it's an exothermic reaction and the energy should be written in the products because it's released. So 1 and 3 is not your answer. So now that we know it's either 2 or 4, the other thing that we need to compare is the mass. So which equation is balanced correctly? So that seems to be, you just have to see if you have same number of carbon, hydrogen, and oxygen on both sides. So that seems to be equation number 4. What is the amount of heat released by 1 gram of liquid water at 0 degrees Celsius when it changes from 1 gram of ice at 0 degrees Celsius? So we are looking at a phase change from water to ice. So that is freezing. And we are trying to figure out how much heat is going to be released when we go from liquid water to solid water. So The equation that you're going to use in this case, remember we had three equations for heat. You either have Q equals MCAT that we use whenever there's a difference in temperature, which we don't see here. So that means we have to use one of the other two equations, either the one with heat of vaporization or the one with heat of fusion. So freezing is the opposite of melting, so that means we're going to have to use the equation with heat of fusion. So Q equals MHF. Because it's just water, the heat of fusion of water is given in table B. It's about 334 joules per gram. So you just multiply that with the given mass, which is 1. So the answer in this case is 334 joules. So determine the mass of liquid water that vaporizes if 7,700 joules of energy is absorbed by water at 100 degrees Celsius. So in this case, we are not actually calculating the heat energy, we are calculating the mass. And we are looking at a phase change, so that means we don't use Q equals MCAT. The equation that we are going to use in this case is the one with heat of vaporization. We are looking for mass, so the equation, when we rearrange this, is just going to be Q divided by heat of vaporization. So Q is given to be 7,700, and we divide that by the heat of vaporization, which is 2,260 joules per gram. So joules cancel with the joules. When you do the math, you get about 3.4 grams. Use information on table B to determine the amount of heat absorbed by water when the water is heated from 20 degrees Celsius to 50 degrees. Because in this case, we do see a difference in temperature. So this is a good example of when we use Q equals MCAT. So the mass in this case is not given, which is interesting. So it looks like this is another example of a question where I forgot to include the text that was given before. So let's assume that the mass was given to be 10 grams. The C is given in table B. The specific heat capacity of water is 4.18 joules per gram degrees Celsius. And then your difference in temperature, remember it's always final minus initial. So we are going to 50 degrees Celsius, so 50 minus 20. If you do initial minus final, you get the wrong charge. So please don't do that. So now we just do the math and calculate the answer. Should be a positive number. During which two processes does a substance release energy? So very quick thing that you can remember is if, let's say, we are starting from a solid and we are converting that to a liquid and then to a gas. In this case, we are trying to move the particles away from each other. So these absorb heat. If, however, we are going from the gas to the liquid to the solid, now we are bringing the particles closer together. So in this case, they are going to release the energy. So the question is asking for something that is releasing, so we can look for something that is, we have freezing, which is going from liquid to solid, or condensation, which is going from gas to liquid. So that is your answer. For the next two questions, we are given a heating curve. Just a very quick reminder, heating curve means we are adding heat over time. So in this case, we are starting with a solid, and then we go to a liquid phase and then to the gas phase. The straight lines represent the phase change. And then remember, the temperature associated with the phase change will be your melting and boiling point. So identify the interval during which the average distance between the particles is the greatest. So that will be your gas phase. So the interval is EF. State what happens to the potential energy of the particles during the melting of the substance. So melting is just one example, but during any phase change, the kinetic energy remains the same, as you can see, because it's a straight line, no temperature change, so no change in kinetic energy. But for the potential energy, it increases or decreases depending on whether we are doing something that absorbs energy or releases energy. So when we are melting something, we are going from the solid phase to the liquid phase. So in that case, we are going to need energy, absorb energy, to move the particles apart. So the potential energy is actually going to increase in this case when the phase change is occurring. So potential energy increases in a heating curve and it decreases in the cooling curve.